Hello everyone, good evening, Maharaj sir. So, representative of Zenith Study Center. So today we are going to read about the central tendency. Before we read the central tendency, we can describe the definition, objective, classification, types of data and their formula, use and limitation of mean. Now, what is the definition of central tendency? Central tendency is a summary statistics. Summary statistic. Or we can say it as a descriptive statistic. So what is the meaning of summary statistics or descriptive statistics? Central tendency gives a single point, single value that represents the whole population. So it summarizes the population. One single point summarize the whole population. So we can call it a summary statistics or descriptive statistics. Central tendency always give single central point. Single central point that divides the whole data into two equal parts. So, two equal parts means a central point. That is 50% right and 50% left. So what is the central tendency? Central tendency is the summary statistics or descriptive statistics that gives a single central points that divide the whole data into two equal parts, that is 50% right and 50% left. So what is the objective? What is the objective of central tendency? First we can say it gives the broad view. Broad view of the population. What is the means of that? Okay, central tendency provides single points. That single points approximate the population characteristics. For example, if you say the average height of the Nepalese people is 5.5, it means that most of the peoples, approximately 95% of the peoples have height line between 4 to 6. Point number 2. It helps in comparison of the data. So, suppose we have to compare the mean height of the Chinese versus mean height of the people, Nepalese peoples. So, you can compare the mean. If the two countries' people's average height is equal, their height is also equal. So, comparison, which peoples is larger, Nepalese peoples is larger than the Chinese, or Chinese is larger than the Nepalese, or equal. So, comparison based on a mean, average, mean. Point number 3, it always provides single points. Single point. So they are the objective. So comparison of data it gives a broad idea. Now, classification. Usually central tendency has central tendency is the two types. It is of two types. Mathematical average or positional average. Mathematical average or positional average. So mathematical average has further classified as arithmetic mean, we can call as A, geometric mean, DM, and harmonic mean. LCM. So positional average is median, mode. So sometimes we deal the MCQs in various examination sectors. For example, with one of the following is a mathematical average. Option number A, median, B, mean, C, range, D, mode. Which one of the following is a mathematical average? Option number A, median. Option number B, mean. C, range. D, mode. So we can deal this option. Mode is the most fashionable. Most frequent. Range is a dispersion. Highest minus lowest. So mode is a positional value. Median is also positional value. Positional area. So you can treat median positional area, mode positional area, range the dispersion. So you can treat the mean. Mean is a mathematical average. Question number 2. Which one of the following is average? Quarter, range, AM, ST. Which one of the following is the average? In this option, we can treat the AM, arithmetic mean. Quartile is a dispersion. Range is also dispersion. ST is also dispersion. Most stable dispersion. ST. So remaining the option C is the average. So now we are going to deal about types of data and their formula. So what are the types of data? Usually mean, Our central tendency can be calculated in three types of data. So, classification of the data, individual data. What is the difference? Individual data or group data? So group data has two categories. One is the discrete, other is the continuous. So what is the difference? First difference, individual data has only X values, data values, no frequency. Discrete data has X values in whole number and frequency. Punch data has also X value, but in range, and also frequency. For example, thus, base, this. Thus, base, this. This is the X value. Here is also X value. Yeah, that's a frequency 2, 3, 4. Now, in continuous data, X is 10 to 20, 20 to 30, 30 to 40. Frequency 2, 3, 4. So we deal the types of data. So doing the questions, numericals about nature of data, we should have to know the formula. So with indirect method, the frequency of mean, what is the formula of mean? Mean is equal to summation x by n. Here, no frequency. So what is the difference between discrete data and individual data? There is a difference of frequency. So formula is also different in frequency. Mean is equal to summation f into x by n. Summation f of x. That is the difference. And what is the formula difference between discrete data and continuous data? So mean is equal to summation f x by n, where x is mean value of range. So we can use the mean direct method. So what is the difference? What is the indirect method, deviation method? Or assume mean method? Indirect method, assume mean method. So we assume a mean. Suppose, so we can calculate the what is the d when x minus a is the assume mean. So you can assume any values like 10, 20, 30, alpha, every is the highest plus lowest. So technically we take highest values plus lowest values by 2. So during deviation method, first we calculate the d is equal to x minus a. So what is the formula of mean by derivation method? So x is replaced by summation d by n. D is equal to x minus a. So we can add a plus summation d by n. So what is the formula of discrete series of data? A plus summation f into d by n. X is replaced by d. What is the formula of continuous data? A plus summation f d by n. Point number 1, point number 2. Point number 3, step deviation method. So during a step deviation, we have to calculate d bar. What is the d bar? D by h. What is the h? H is the class interval. It means that x minus a by h. Step deviation cannot be applied to individual data. We do not can be applied in also discrete data. So step deviation method of mean can be used in continuous data because here is the range a plus summation f d dash by n. Here, during calculation of step deviation, d dash d by h. So we have to neutralize it by multiplying s factors. So this is the formula. Can you assume what is the direct method? X method mean is equal to summation x by n. Deviation method x is replaced by d. Here a is assumed mean. So d is equal to x minus a. So a plus. Here we add a plus because d is equal to x minus a. A plus summation d by n. Formula is the same. Summation fx, summation fd, x is replaced by d. A plus summation fd by n. Likewise, continuous series x bar a plus summation fd by n. So step deviation, we cannot calculate the step deviation method in individual data because there is no h, no range, no in a discrete data also. So we can calculate step deviation method in only continuous data. So we did the definition, objective, classification, types of data, their formula. So what is the use and limitation of mean? So before going to deal a limitation of mean, I want to describe some example of arithmetic mean, calculation of arithmetic mean. For example, we have such a kinds of data. For example, calculate the mean of flowing data. Thus, this. So here solution. This is the individual series of data. This is the individual series of data. X is equal to thus base this. No frequency. So according to me, for individual data, summation x by n. So first of all, we have to add this, b 50, thus 60. Summation x is equal to 50. Now put the data in a formula. Summation x 60. What is the n? 1, 2, 3, 20. So now likewise, the sum population about discrete series of data. Calculate the mean for flowing data. X thus is this. There is a frequency 2, 3, 4. So this is a discrete series of data. So now, before doing the calculation, solution x thus is this. Frequency 2, 3, 4. Now we should have to memorize the formula of mean is equal to summation fx by n. So need fx. So now in table we can calculate the fx. 10 to the 20, 23 the 60, 30 for the 120. Now summation fx. So we have to add this. Summation fx is equal to 80, 200. And now n is equal to 13 sa we know. So 200 by 9. Likewise, so we can calculate the mean for the continuous series of the data. Question number 3. Calculate the mean for the flowing data. X 10 to 20, 20 to 30, 30 to 40. Frequency 2, 3, 4. So now, procedure solution x 10 to 20, 20 to 30, 30 to 40. Frequency 2, 3, 4. Now we have to calculate the mean value. X 10 plus 20, 30 by 2, 15. 20 plus 30, 50 by 2, 25. 30 plus 40, 70 by 2, 35. So, formula of continuous series of data, summation fx by n. So need a fx. Now fx 15 to the 30, 25 to the 75, 35 for the 500 का 20, 140. Now we have to add that this 40, 70, 70, 75, 75, this 105 plus 40, 1, 2, 45. Is it okay? This 75, 140, 70, 175, 25, 200, yeah, 140, 75, 30, 5, 7, 3, 10, 4, yeah, 245. Now, we use the formula 245 by 9. So, here we did the calculations based on types of data. So, before doing the step deviation method, so now we can prove this questions by step deviation also, and division method also. So 10, 20, 30. For example, by division method. Division method. X 10, 20, 30. So we can calculate the assumed mean. What is the assumed mean? So A 10 plus 30 by 2, 40 by 2, 20. Now, so D x minus A. So 10 minus 20 minus 10, 20 minus 20, 0. 30 minus 20, 10. So according to formula, we need a, so what is the division method of formula? Summation D by N. So what is the summation D? Summation D, 10 minus 10, 0. A plus, what is the A? 20, 20 plus 0 by 3. It is the 20. So here is also 20. So same kinds of data, by applying different formula, deviation of a direct method, the mean is same. So if you have a difficulty to calculate the deviation method by discrete data, then you can take the example. This is the example of discrete data. So in deviation method, how we calculate it? Deviation method. Here we can give x 10, 20, 30. Frequency 2, 3, 4. So we can calculate the assumed mean. What is the assumed mean? 10 lowest value plus highest value 30 by 2, 20. So we can calculate the D, x minus A. So what is the x? 10. The 10 minus 20 minus 10. 20 minus 20, 0. 30 minus 20, 10. So discrete set of data, the formula is mean A plus summation FD by N. We need FD, not a D. So now FD. So minus 20 into 2, minus 10 into 2, minus 20, 3 into 0, 0, 10 into 4, 40. So what is the summation FD? 40 minus 20, 20. Now, so what is the mean? Assume mean 20 is summation FD by 20 by N, 3 to 5, 9. So now we calculate